In the previous video, we have learned how to measure energy use. We will now look into how these units are used, for example, on a national scale. Once we know how to measure the various flows of energy in a country, we can put these into one system. We call this an energy balance. An energy balance is used to provide an overview of important energy flows and their sources, and can be for a country, region, or even an individual company. An energy balance consists of three basic elements. First of all, we start with the end use. Where is energy actually used? This is broken down on a sector-by-sector basis. For example, how much energy used is used in different industrial sectors or for transport. The sum total of the energy use in these different sectors is called total final consumption. The second step is that we determine how the energy use is converted and distributed to get to the final user. If the energy is delivered in the form of electricity, then it must be produced in electricity plants. If it is delivered in the form of gasoline, then it must first be refined. The sum of these conversions and distributions is the total energy supply. And finally, we determine where does the energy come from? Where was the original source of this energy? Some examples are highlighted here in yellow. Let us now look a little bit more in detail. The energy balance takes the form of a matrix, whereby each row represents a sector and each column an energy carrier. In this slide, we will slowly build up a simplified example of an energy balance. We start with final energy use, and now it's broken down by sector. You can see rows for the industry and transport sector. Others have been combined in this example. The values show the breakdown by energy carrier of final energy use in these sectors. Together, these values sum to give the total final energy consumption for each sector that you see in the red colored row. Now we add the second part, and that's the conversion sector. You can see on each row the various conversion sectors like electricity plants and oil refineries. Energy conversion sectors have energy as both an input, negative numbers, and an output, positive numbers. For example, looking at the row for electricity plants, the energy carriers coal, natural gas, nuclear and hydro, solar and wind are used as inputs and so are negative. These are converted to produce electricity output, which accordingly has a positive value. Now you also see there is a balance in the system. We can start with total energy supply. Part of it is converted in the energy conversion sectors. The remainder is available for final consumption. For example, we see that 170 units of coal are used in this country, of which 120 units are used to produce electricity. The remainder is available for final consumption, for example in the steel industry. If you compare total energy use to final consumption, for most columns you see that we have lost energy because of this conversion, but in return we have gained electricity. Then we move to the third and final element, and that is, where does all this energy come from? A country can produce its own primary energy. For example, this particular country extracts 300 units of crude oil out of the ground. But in addition, energy can be imported. This country imports 20 units of crude oil. This will be added. But countries can also export energy carriers, in which case the value is subtracted. See in this example natural gas. What remains is the energy available to a country. This is the total energy supply. Production plus imports minus exports. So this is a fairly simple overview of how energy balances exist for many countries. In the exercise for this video, you will get to have a more hands-on experience with these concepts. It's important to remember that the energy balance is based on an important principle, and that's the law of conservation of energy, which states that energy can be neither created nor destroyed. As such, there must always be a balance between the various elements of the energy system and between the elements in the energy balance. In reality, energy balances have much more detail than what is shown here. They are available for all countries in the world and are published internationally by the United Nations and the International Energy Agency. More information on this will be provided in the material after this video.